All right, good afternoon, everybody. Well, Fire Tablet. Good afternoon. Who is Fire Tablet? Who is that?
Takish, sir.
Hey, Takish, what's up? You
Hi.
good?
Yes.
All right, great. So we are the ones. Well, you're here in the Zoom so far, and some people are on YouTube. Hello to everybody on YouTube. I'm seeing Chinora, I'm seeing Katya, I'm seeing Christina and Ninja Starman. All right, Ninja Starman. Ninja Starman, yeah, you can believe exam is just a month away. Like by the time you look, exam just reach. Yeah, it's really, really close. So I will just have to make sure we get in as much prep as possible. Uh, And once you do that, then you'll be good. You don't have anything to worry about. You know? So it's good that you're here. Because that means you want to make sure that when the exam come, it sort out good. Hi. Hey Genesia, what's up? Good?
Much.
Alright, great. So for those who are on YouTube, you can, of course, you'll be able to type in the chat if you want to join in on thing there. If you want to join in on Zoom as well, you can click the link and stuff. So I can, if you want to ask a question, like if you want to talk or anything like that. No, them can no, Leona, they look like them going push it back. Don't look like them going push it back. So we have for this work with it. But all you have to do, you just make sure, what I usually tell everybody, just take like 20 to 30 minutes a day and just set aside that time for math. Since the exam is coming up, then you know you want to spend like, probably you can set like an hour, 30 minutes to an hour. So you just try to get that practice in, right? And you should be good to go. So since this is going to be live streamed and since it's going to be saved, I guess we can just go ahead and start. And then anybody else who joins, they can come along as well. All right. So we are going to be looking at sequences. That's what we're focusing on for today. That's what we're focusing on for today. Hello, Ram Mario and Galaxy Tab A. I wonder who that is. Let me where am I? Oh, just give me 1 minute. Let me get something up. Yeah, that is it. Yeah, Leona, 3 weeks left. Like by the time you turn around. By the time you turn around. So what we're going to look at today, we're going to focus on sequences, Zin, and what we're going to do is we're going to see this topic. If you guys have watched my video on if you guys have watched my video on topics, the topics that they're going to ask in the exam, then you can get an idea of some of the stuff that you know, the 5 main topics that we see every year. So sequences is one of them, and if you watch those videos too, you know that sequences is my top pick. Kind of comes back every year, and it kind of comes back the same way every year, so it's kind of predictable, to be honest. So you can see them the same way, you can expect it, and what you'll be doing is pretty similar. So that's why I want to look at some sequence questions for today. But today we are mainly focusing on sequence questions from the past paper, from exams. So if you've done the sequences as a topic already, you can let me know. So talk to me. Have you done sequences already? Like patterns and stuff like that?
Yes, sir.
You've done it already. All right, great. So we're gonna kind of recap a little bit of what it's about and then go straight into like the exam questions. All right? So on a scale of 1 to 10, let's start with that. On a scale of 1 to 10, write it in the chat. Where would you rate yourself with sequences? Do you say you're like sequences master, or you're gonna put yourself at like a 1, you're not so sure, or something else. All right, so Christina said 8.5. That's good to hear. That's good to hear. That sounds good. So let me draw our little thing here. What about the rest of us? And even those who are on YouTube, you can still put it the same way. So from 0 to 10, we know we have a Christina at 8.5. So we're gonna put you here, Christina. See it? You get your own spot on the line. All right, Starman say 8. So I'm gonna put Starman could be close to here, so for argument's sake. Ninja. And Liana says 7, so I'm gonna put Liana here. So we're gonna try and move those up, but all over, I think that sounds like we kind of have an idea. Oh, Latoya Stewart is saying 1. No problem, Latoya. So we're gonna try and move that 1 up to at least an 8 or a 9 after we finished. Zin? So let's get started. Let's see what we can do. Now, first, let's kind of recap what you know about sequences. So let's see some of the stuff that we're kind of familiar with, that we're kind of aware of when we talk about sequences. What are some of the stuff that we already know? We know that when we look at a sequence, let me start you off. When we look at a sequences look something like this. Like this is an example of a sequence, right? So when we talk about sequences, that's what we're talking about. Sometimes it can come visually too. So you can have like something like a different pattern. So like a pattern of dots, something like that. And then it continues to something like that. So we know it's visually. And you know, we can also have a rule that describes a sequence. So when we talk about rules in sequences, you know, we're talking about stuff like the nth term, or something that can describe any sequence that you've seen already. Jogging your memory so far?
Yeah.
All right, good. So one of the things that I want us to cover, just to make sure that we're able to do when we talk about sequences, is making sure that you know how to find the nth term of a sequence, because that's really, really important. Because when you look on when we look in the CSET report every year, students can continue sequences, they can draw the diagrams, but they might have difficulty finding the nth term of the sequence or the rule of the sequence. Okay, so what do we mean when we say the rule? Let's look at an example. So let's say that we had something like this. Let's say we had a sequence that was 10, 20, 30, and so on, right? Now, when we talk about the rule or the nth term of the sequence, it's kind of like a key. It's kind of like something that we can use to figure out other stuff that are in the sequence. See? So it links your position, where you are in the sequence, to the term in the sequence. So, like how we have the first term here, the second term here, and the third term here, write in the chat for me, what would be the fourth term in this sequence? What would be the fourth term? I'll put that in yellow. What would be the fourth term? All right, Christina is saying 40, and Ramaria is saying 40. Yeah, that's right. So 40 would be the fourth term. Let me ask you a little further. What would be the 12th term in the sequence? The 12th term. What's the 12th term in this sequence? All right, so 120. Yeah, that's right. And then finally, what would be the nth term in the sequence? What's the nth term? So now we take it a little step further, because now we're not talking about a number, we're talking about an nth term. And this can describe any term that's in the sequence. So what would that be? All right. I'm seeing Christina saying n times 10. Anybody else agrees with that? N times n or n times 10 or 10n? What do you guys think? What do you guys think? So do we say that it's 10n? Christina, how you know that it's 10n? You know it's 10n. Tell us how you know.
Because realize you have to times the nth term by 10 to get like the number, the correct number.
Yeah. So the first term is like 10 times 1. The second term is 10 times 2. The third term is 10 times 3. So the nth term is going to be 10 times n. Great. Yeah, that's it. That's very good. That's right. Now let me ask you a question. What about this sequence? So what about this one down here? Let me put it in green. 12, 22, 32. What would be the nth term of this sequence? What do you think? Again, let me see it in the chat. What do you guys think the nth term of that sequence would be? What do you think? I want to think about that one. So now remember, the nth term of the rule links the position to the sequence or the term in the sequence. If you're not sure, type a n in the chat. If you're not so sure what that would be. If you're like, I don't really know. I don't know. All right, I'm seeing some people thinking n plus 10, right? But then if it was n plus 10, that means the first term would be 1 plus 10, and the second term would be 2 plus 10, and the third term would be 3 plus 10. But that's not what we're seeing here, because 1 plus 10 is not 12, 2 plus 10 is not 22, and stuff like that. So that wouldn't be it. But now guess what? Think about it this way. You notice that these two sequences are kind of similar. What's similar between the two of them? So from 10 to 20 and 20 to 30, 22 to 32. Do you notice any similarities?
Increasing by 10.
Yeah, it's going up by 10. Just like this sequence 10n. Yeah, everybody seen that? So it's like 10n. It's like the sequence 10n. But what's the difference? What's the difference? So it's like the sequence 10n, but instead of 10, it's 12. Instead of 20, it's 22. Instead of 30, it's 32. So you guys notice it's always 3 more. You see that? Who see that? Sorry, 2 more. Who see that? So it's like 10n, but it's always 2 more. Yeah or no? Are you not really seeing it? Let me check the chat. Oh, yes, Christina says she see it. All right. Trudy, I see Trudy on YouTube got it. Right. Great. Pretty good. But I don't want to leave anybody behind. I want to make sure all of us get it. Romario say you see it too. All right. Good, Romario. Yeah. Nice. Pretty good. Ninja say him get it. All right, Ninja. So that is it. So it's like 10n, but it's always 2 more. So how can we show that? That means the nth term would be 10n plus 2. Because we're saying it's like 10n, but it's always 2 more. You understand? So that is that we could say that this is the nth term of our sequence. So anytime we have a sequence that has a constant difference, it goes up by the same amount all the while, then we can basically just see what timetable it's like and then see how far away is it. Right? Let me see if you really get it. Let me make sure. What if I had a sequence that was 15, 25, 35. What would be the nth term for that sequence in blue? I'm looking now in the chat. What do you think the nth term for that sequence would be? All right. See some answers on Zoom. Let me wait and see if I see anything on YouTube. Right. Yeah. You guys, hey, you're not going. Yes, that is it. 10n plus 5. Because it's like our our 10 times table, 10n, but it's always 5 more. All right, last one now. Last one. Just to make sure you're good. What about this one? 4, 7, 10, and so on. What's the nth term for that sequence in red? What's that nth term? What are you thinking? Look at it, good enough. Look at what timetable, think about what timetable is it like and how far away is it? So what are you guys thinking? Let me see. Let me look in the chat. All right. So now, think about it. How much is this sequence going up by?
3.
3. So what timetable is that? That's our 3 times table, right? So we know that the nth term for our 3 times table, it must be 3n. Because 3 times, the first term is 3 times 1, the second term is 3 times 2, the third term is 3 times 3, and so on. So it's like our 3 times table, it's like 3n, but what do you notice about each of the terms?
Yeah, I don't
Instead
know.
of? Yes, very good, Christina. So it's always one more. So instead of 3, it's 4. Instead of 6, it's 7. Instead of 9, it's 10. So it's like 3n, but it's always one more. So that's why the nth term would be 3n plus 1. Huh? Yeah. If that's good, if you're clear, if that makes sense, if you see it now, put a thumbs up in the chat. And if you're not so 100, like you saying, I don't know about that, put a thumbs down or N in the chat so I can know what you need help with. All right. So you see, it's like your 3 times table, but it's always one more. And that's how we think about that's one way to think about the nth term. Because you're just looking for a pattern, you know. You're just looking for a pattern. So once you can pick out that pattern, then you can do it. All right. As is one person saying they want one more example. So let's do one more example. What color can I use now? Back to white. Yeah. What about what about, let me see. What about 8, 13, 18? What would be the nth term for that one? What would be that nth term? Whew. Yeah, sorry. What would be the nth term for that? So remember, you're thinking 2 things. What timetable is it like? And how far away is it? All right, so one answer so far from Ninja. I could see if anybody else find that or if they find something different. All right. Yeah. Great, guys. Great job. 5n plus 3. Very good. I'm seeing that. It's 5n plus 3. Because it's like your 5 times table, but it's always 3 times more. So instead of 5, it's 8. Instead of 10 it's 13, instead of 15 it's 18. And that makes sense because think about it. For the first term, it would be 5 times 1 plus 3. And 5 times 1 plus 3 is 8. For the second term, it would be 5 times 2 plus 3. That's 10 plus 3, which is 13. For the third term, it's 5 times 3 plus 3. And that's 15 plus 3, which is 18. So you see how all that connect back together? So it just links the position to determine the sequence. That's the part. So this is what I tell you is kind of like a key. So it's kind of like this. So key, look. I miss out the bottom part of the key. So it's kind of like a key that you can use to unlock the sequence. You can find any term in the sequence once you have, or once you know what the rule for the sequence is. All right? So since we get that in mind, since we have that in mind and we know what a sequence is, I remember that this works. This is what we're thinking for sequences that have a common difference. We call them arithmetic sequences. Then should be able to solve. One more question though before we continue. What if I had a sequence like this? What if I had this sequence? Let me put it in red. 1, 4, 9, and it continues. And let me put two more terms. 16, 25, and so on. What do you think the nth term would be for that sequence? What about that one? Or the rule for that sequence, rather? Same thing still. What's the rule? So now remember, I know, look at this sequence carefully. This sequence is not a, it's not going, look first you have to check, is it going up like by a constant amount like a timetable? So that very carefully. If it is, that'll be good to go. But if it's not, then you're going to have to think about it a little bit more. So just look at the numbers, because I just wanted to find the pattern. That's what you're looking for. You're just looking for some type of pattern. You know what I mean? So what you guys thinking? Alright, I see main man and ninja saying n squared. Ooh, it would be too much for you to type out that. But anybody else thinking that pattern, n squared? Anybody else see it? Or they don't see it? Yeah, that's like, I don't know. True, Mario, it's a pattern. It's definitely a pattern. But we just want now to find a way to describe the pattern. Christina, say you see it. All right. So if we look, yeah, make a look at it. So 1 n squared. Thanks for that, main man and ninja, yeah, because the first term would be 1 squared. The second term is 2 squared. The third term is 3 squared. The fourth term is 4 squared. The fifth term is 5 squared. You see that? Because 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. So the nth term will have to also be n squared. You see? Because that's what's happening for the sequence. So the reason I show you that one too is that not every, you see how we're thinking, you have to look for the pattern. You have to just make sure that you see the pattern in the numbers. Okay, so it's not like we say we just use one way to do it all the while. Just look for the numbers to see if they have a pattern, and then we move from there. So with all of that being said, let's see if we can start doing some CSEC questions. Now, here is the first one that we want to try. So here it says that a sequence of figures is made up of unit squares with unit sides. The first 3 diagrams in a sequence are shown below. Well, this should be to the right. and we want to draw the fourth diagram in the sequence, and then complete the rows numbered 1, 2, 3, and 4 in our table. All right? So come with me now. We want to draw the fourth diagram in the sequence. I wonder if anybody in Zoom can annotate on the screen and draw the fourth diagram on our figure right here. Who is able to do that? Who can do that one for us? You kind of say, I don't want to try it. All right, guess what? I'll do this one, but you guys have to do one. I'm not doing all of them. You guys are gonna have to do one. So who can kind of tell me, what do you think the next figure is going to have, or the next figure 4 is going to look like? What do you think? Figure 4. What do you think? Let me see who is thinking about it. Where would I put the squares here? Where would I put the squares? Can you notice if you look at figure 1 to figure 2, you see the pattern? It's like it's adding some out here. So you added 1 on each side. Up, down, left, right. Next one now, we added 2. So we added another set of squares. Okay, so it's kind of like if I could draw on it, we had these already. And now we added a new set. One here, one here, one here, and one here. So now in figure 4, it must mean that we're going to add on some more. So if we put that now in red, that means it must mean we're going to add one here, one here, one here, and one up here. So this is what our fourth figure would look like, right? As we notice, we're just adding 1 at the end each time. Everybody good so far? That's clear? That makes sense? Can put a thumbs up in the chat, let me see if we're good.
Sorry, you can go over it again if you don't mind, please.
Yeah, man, no problem. So we're looking at the pattern, right? We're looking for something in common that, we're looking for a pattern for it each time, right? So if you look at the figure, you'll notice that here we had 1, and then for the next one we added some squares at the top, the 2 sides, and the bottom. We did it again over here, so that's the one that we have in green. So now if we're going to get the fourth figure, it must mean that we're going to add a square here, 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 and here. Yeah? Which is what I would have in the diagram over here. Yeah? See it?
Okay.
All right, good. All right, now let's go to the next one. So it says we want to complete the table. We want to complete the rows numbered 1, 2, 3, and 4. So now we're going to think about it. We're going to think about each term in the table. Yeah. So we have the diagram right here, and then we are missing a space for the number of squares and the perimeter of the figure. So for example, in this row, numbers, in this column, number of squares, we have the first one has 1 square, we see that. The second one says 5 squares, and we can count that, 1, 2, 3, 4, 5. The third one said 9 squares, and we can count that. So how many squares are in the fourth figure? Let me see you write it in the chat. How many squares are in the fourth figure? All right, Christina said 13, and that's right. Because when we count it, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. That's right. So that would be 13 squares. Now, what's the perimeter of the figure? For the first one, it says the perimeter is 4. Remember, perimeter is the distance around it. And we can see that because the distance around here, 1, 2, 3, 4. For figure 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Again, we can see that one. And for figure 3, we see that it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So now what's the perimeter of the fourth figure? What would its perimeter be? Let me see your answer in the chat. All right. So Mario wrote 28. Anybody else seen that? 28? For the perimeter of the figure for figure 4? Seen 28 too? All right, Christina see it too. People on YouTube, you seen the 28 too? For the perimeter of the figure? Reminder, we're not leaving anybody behind. But you see that the perimeter for figure 4 is 28. Yeah. So if we, that sounds like everybody sees it. All right. Yeah, so the perimeter will be 28. Good. Now, we still want to complete the table. If you look in the next row, for row 2, you notice it's missing, the n is missing, the n, what diagram it is, and the perimeter of the figure. So you remember when I said the nth term is like a key? You can use it to figure out any other term in the sequence, okay? Now, how could we do that? Let's try and find the nth terms first and foremost. So for the number of squares, what would the nth term be? So see the sequence here, 1, 5, 9, 13. What would the nth term be here for that, for the number of squares? What would it be? I think Christina thinking 4n minus 3. Christina, oh, you know that is 4n minus 3. You can tell us?
I just look at the sequence. Let me explain. We just follow the rhythm or something.
So yeah. You see so you're thinking about the difference. So we see it's always 4 more, so it's like 4n, but it's 3 less. Instead of 4, it's 1. Instead of 8, it's 5. Instead of 12, it's 9. All right, thanks for that. So that would be our nth term. What about the perimeter, the nth term for the rule for the perimeter of the figure? What is that? What's the rule for that? And I think I saw it too in the chat, you know. What's that rule? Oops. What's that rule? Write it in the chat for me. What's that rule? What is that? Look at the terms. Look at the terms in the sequence. So we have 4 to 12, and then 12 to 20, 20 to 28. What do you notice? What's a pattern? Yeah, then we go to the chart here. I see main man say it's 8n minus 4. That's right, because it's like our 8 times table, because you notice it's always 8 more. right? So it's like our 8 times table, but instead of 8, it's 4. Instead of 16, it's 12. Instead of 24, it's 20. So it's like 8 times, but it's always 4 less. So it's 8n minus 4. All right. So now that we have those, the keys to the sequence, as I said, now we can figure out, we can use it to help us solve for all of the other parts in the table. For example, we know that the number of squares is 45. What do we know? We don't know what diagram it is, but we know that whatever diagram it is, it's going to be equal to 45. Yeah? So we could count up, you could try and count up until you reach the 45, or you could use the key, the nth term. So for that one, for number 3, we know that the 4n, whatever it is, it's going to be equal to 45. And since we know that, then we can solve for n. You see it? Which is whatever diagram it is. Yeah? Everybody with me so far? Give me a thumbs up in the chat if that's clear. So we can use this to figure out what our diagram is. Because if 4n minus 3 is 45, that means 4n is going to be 45 plus 3, which is 48. And if 4n is 48, 4 times what gives us 48? Has to be 12. So n is going to be 48 divided by 4, which is equal to 12. So we know that the 12th diagram has 45 squares. And since the 12th diagram has 45 squares, what will its perimeter be? What will the perimeter of the 12th diagram be? This part right here, what would this be? What's that going to be? You can write it in the chat. I'm going to give you a chance to think about it, to work it out. So what's that going to be? All right, I'm seeing Christina saying in the chat 92. And if we check that out, 8 times 12, that's 8 times 12. 8 times 12 is 96 minus 4. 96 minus 4 is going to be 92. Great, that's right. Yeah. So the perimeter would be 8 times 12 minus 4, which is 92. All right, great. Good job. Good job. Now, look at for the 30th diagram. What's the number of squares that's going to be in that one? What's the number of squares that's going to be in that one? Again, I'm looking in the chat to see what you guys have. I'm not seeing or hearing from some people though. I just want to make sure that everybody good enough. What's happening? iPhone, you good so far? Fire tablet. All right, iPhone, I hear you. Or I see you. So it's 117, because that would be, for the 30th term, it would be 4 times 30 minus 3. That's 120 minus 3. Oops, so this was the second one actually. So that's 117 for the number of squares. And what's the perimeter of the figure? Okay, fire, I see you. So for the perimeter, Christina said 236. Let's try that. So that's 8 times 30 minus 4. So that's 240 minus 4, which is 36. So that is correct. So that is 236. All right. I'm seeing Ninja saying it's still not sure how we found the n values. So let's go to our table, right? So remember, we said we just look at what timetable it's like, and then we see how far away it is. So look at this one. Look at so from 4 to 12 to 20. So think about it. It's always going up by 8. What timetable is that like? That's like an 8 times table. So we know that our 8 times table is, the nth term for that is 8n. Because to find any term in that, 8 times 1 is 8, 8 times 2 is 16, for the third term, 8 times 3 is 24, so for the nth term, it would be 8n. Right? So it's like our 8 times table, but what's the difference? I write it here. Instead of 8, it's 4. Instead of 16, it's 12. Instead of 24, it's 20. So it's always 4 less. It's always minus 4. It's always minus 4. So it's like our 8 times table, but it's always 4 less. So that's why we say the nth term is 8n minus 4. That clears it up a little bit. Does that help? All right, great. Good to hear. Great. Okay, let's try another CXC question. Now I want you to look at this one. So it says a sequence of figures is made up of equilateral triangles called unit triangles with unit sides. The first 3 figures in the sequence are shown below, and you're supposed to draw figure 4 of the sequence and then complete the table. So you see, it's kind of doing the same thing again, but it's a different type of sequence. So you just have to look on the numbers. So guess what now? I'm going to give you about 2 or 3 minutes to look at it. Get my stopwatch. I'll give you about 3 minutes just to make sure you get the sense of it. And then we are going to look at it together. All right? So let me get my little stopwatch here. 3 minutes. And go ahead. Think about it and see if you can figure it out. And fill out the table too. And you know what? For those who are in Zoom, you can send me your answers like privately, because we want to give everybody a chance to answer, but you can still send me your answers of what you found, especially when you're completing the table, right? All right, me and man, I see what he's saying in the chat. Hold them a little bit. Hold them a little bit. We're gonna take them in a few to see if you can, that can help you to figure out the stuff on the table. Ah, no, you sent it. So say, let's hold it a little bit. Hold it a little. 'Cause I want everybody to get a try. I'm gonna have to take that one away. 'Cause I want everybody to try it. So I soon come back to you. Yeah? Yeah. All right. So let's see if we can figure it out. So I'm gonna do it, and then we are going to kind of again, if you have any questions, you just ask me while we go along, right? Now we want the fourth figure. So to get the fourth figure, we need to find a pattern. So let's start. We have figure 1, this triangle that looks like this, looks pretty normal. And then for figure 2, what do we notice? We have a triangle here, but it's like you added the same one, but we added 3 at the bottom. That looked like that, right? And then for figure 3, I like to kind of color them just to get an idea of what's changing. So we had this, and then now we have, let me put it in blue, we had these down here. So you see what's happening? So the first time we added what? 3 triangles at the bottom. For the second time, we added 5 at the bottom. Anybody else seeing it a different way? Because there's a lot of different ways to look at it. Anybody else was looking at the pattern differently? Or you kind of saw the same thing? Probably, you might see it different ways, and that's the point, because it's good to see it in another way. So now that means, oh, Ninja, you saw it differently. If you're able to type it out, that would be great. You can type it in the chat and tell us how you saw it, because that's the point. You can see it in a lot of different ways. That's just how I saw it, but you can probably see it another way. So now that means for the fourth figure, so for figure 4, oh, let me kind of, I shouldn't copy all that in it. Hold on. Oh, it's Ninja said you're seeing the triangles in the middle are increasing by 1. Triangles in the middle are increasing by 1. Ah, yeah. That is it. Okay, you can, all right, let me copy this first, just to show. So let me put this here. We're going to figure 4. But oh, you saw it, that's good to Ninja, because look now. Check out these. So you see the one in the middle. So like the one in the middle, but you get increasing 1 each side. Again, like the one in the middle and the one before, but they are increasing at 1 each side. Anybody else see that pattern? Anybody else saw it like that? That's
Yes.
pretty cool. Oh, you saw it like that, Christina? Yeah, that's another way to think about it. Very good. That's another way. So now for the next term, we can kind of complete it same way. So it just means we're going to come back down here, and we're going to do our little thing. So before it was 5, so now it's going to be 7. And your fourth figure is going to look something like that. A little something like that. Well, let me put it in red. It's kind of like, now you see 7 of them. Right? So yeah, that's figure 4. So that would be our diagram for figure 4. Now we want to study the patterns and complete the table. So let's do that. So now we have figure 4, and in figure 4 it wants the number of unit triangles. What's the number of unit triangles? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Sorry, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So it's 16 units triangles. No? It's going to be 16 unit triangles. And what's the unit size? How many unit size? How many unit sides? There are different ways that we can think about that one too. You know, some people might be going straight to the nth term, or some people might be joining it, or some people might be counting it. Either way, either one is good. You know? So what did you guys get? You can write it in the chat for the unit sides for figure 4. What do you get? Let me see what you find. I want us to do this one together. Or you're not so sure what it is. If you're not so sure, type a N in the chat. If you're not so sure what the units, how many unit sides are there? Oh, you're still doing it. Sorry. You counted it up. Like I said too much. All right, do you think? Do you think? All right. All right. I see an answer in the chat that says 16, but that's for the number of unit triangles, not the number of unit sides. So when we're talking about the unit sides, we're talking about these stuff. So like 1, 2, 3, 4, 5. Let me use that. So we could even count it together. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. I'm seeing main man saying 30. Yeah, that's right, main man. 19, 20, 21, 20, 23, 24, 25, 26, 27, 28, 29, 30. That's right. So it would be 30. All right. Thanks for that. Now, again, we could go straight to the nth term to help us out. Because if we look at the number of unit triangles, what's the nth term? And I think I saw that in the saw that answer on YouTube earlier. So it would be n squared. Right, n squared. The first one is 1, the second one is 4 or 2 squared, the third one is 9 or 3 squared, the fourth one is 16 or 4 squared. So we could say that the number of unit triangles is the position squared, whatever the position is squared, or n squared. And so that could be our nth term. Now, what about the number of unit sides? What's the nth term? Let's look at the numbers. Let's look at the pattern. Let's try to kind of compare what we have with the numbers, with the figure. I'm just realizing, guys, you guys are sending me tons of messages in the chat, but I didn't see them for Zoom. Sorry about that, because it was just sending to the host. So yeah, let's look at that. I'm seeing Christina say 3n times n plus 1 over 2. And that's right, because look at it now. We have 1 here for the first figure. We have 2 here and 2 here for the second figure. We have 3 here and 3 here for the third figure. So for the nth term, it's just going to replace those numbers with n. So it's going to be 3 times n plus 1 all over 2. Yeah, so just look for the pattern. Just look for the pattern and you see. So now that we have our rules, then that can kind of help us. Because if the number, let's go to the second one. If the number of unit triangles is 144, then what figure is that? What figure is that? Yes, it would be 12. Thanks for that. Because 12 squared is what would give us 144. And now, what would be the number of unit sides? So number of unit sides. What's the number of unit sides? Now we're going to have to probably do a little work for that one, right? Because we have this here. So now we could just substitute. We'll do some substitution, because that would be, for the 12th figure, it's going to be 3 times 12 times 12 plus 1, all divided by 2. 3 12s is 36. 12 times 1 is 13. That's all over 2. I should have probably write that outside, you know. Let me write it here. So that's 36 times 13 divided by 2. 2 into 36, that's 18. So that's 18 times 13. And what's 18 times 13? 18 times 13 is 234. Yeah, I'm seeing that answer in the chat. Mainman and Christina. So that means the number of unit sides would be 234. Last one now, 25. Well, we have the nth term, so we can just put them in. So n squared, so that's going to be 25 squared. And what is 25 squared? 25 squared is 625. Likewise, we need to put in the 25 in our rule. So that's going to be 3 times 25 times 25 plus 1, all divided by 2. And now let's do a little working out. So that's 3 times 25, 75. 25 plus 1, 26. So that's all of that over 2. And now 75 times 26, that is, well, we can cancel. That's 2 into 26 is 13. So that's 75 times 13. And we have our calculator here at them, Christina. Yeah, that would be 975. Because that's 750, and I don't have my calculator. Wait, where's my calculator? But that's going to be 75 and 750 and 275. So 225. Yeah, so that's 975. That's right. Good. So that would be 975. And so that, just like that, 11 marks. 2 marks for the right. Well, for figure 4, that was supposed to be 2 marks. And then, 10 marks, not 11. Because 2 marks here, 2 marks here, 2 marks here, and 2 marks here. So that's 10 marks on the exam. You know how far that carry? That carry really far. So again, you can see the different type of sequences. So I think we can kind of stop here. You know what, guys, though? There's this one question. This sequence is question throughout everybody in 2019. It wasn't really much harder, but it just looked different. Everybody said, oh, that look, they're just not used to seeing it like that. And I'm not going to do the first part because, you know, we've been here for a little while, but I'm going to do the B part of it, the part that gave a lot of people problems, okay? And the reason we're doing this is that not every sequence is going to look like, you know, it's going to come with a diagram or something like that. But remember, we're just looking for a pattern. So let's look at this one a little bit, or a little in a little more detail. So this was 2019 was what? Yeah, I think it was June. And as I said, every year, well, for this year, a lot of people didn't get this sequences question. So this is the first 8 terms of another sequence with the nth term are 1, 1, 2, 3, 5, 8, 13, 21. Let me see who really loves math. I wonder who can tell me what sequence this is. Who can tell me what sequence this is? This is a very famous sequence. A very, very famous sequence and a very popular sequence. Who can tell me what it is? Who can tell me what it is? Or we're not so sure. We never see this sequence yet. Type in the numbers online and see what come up. 1, 1, 2, 3, 5, 8, 13, 21. What type of sequence is that? Very, very famous sequence. Nobody don't know it. You guys don't love maths now? Joke. I think you love the maths. But look, it's a very famous sequence. I'm telling you, it's really cool too, because you see it in a lot of stuff about nature and stuff like that. So this sequence is called the Fibonacci sequence or the Fibonacci series. So look that up. Later on, look up that series. Sequence, sorry. The Fibonacci sequence. It's a really popular, it's a really well-known sequence, and it comes in like nature and stuff. But anyways, look it up on your own. So oops. Yeah, oh Akim, yeah, right. Fibonacci. I didn't see your answer. Yeah, you know, oh Akim. Yeah, well, I love the maths. That's good. So, anyways, it says the U1 is 1, and we can see that. What does this mean? This is just telling us that the first term is 1. Because remember, it tells us the nth term is UN. So U1 must be the first term. U2 is the second term. U3 is the third term, and so on. That's what it means. And now it's telling us that the second term is 1, which we can see it for ourselves. And UN is equal to UN minus 1 plus UN minus 2 for n is greater than or equal to 3. Don't make, even if it look confusing, don't make it fool you. Because what all it's really saying, it's just saying that this is the rule for the sequence or the nth term. And here, UN is equal to UN minus 1. In other words, the term that was behind it, plus UN minus 2, the term that was 2 spaces behind it. Understand? So for example, U5 is going to be U4 plus U3. So U5 is going to be U4 plus U3. The number behind 5, which is 4, and the number 2 spaces behind 5, which is 3. U7 is going to be U6 plus U5, right? Because 6 is one behind 7, and 5 is 2 behind 7. Everybody following me so far and what the pattern is? So what it's saying is that basically it just adds the 2 numbers before it that came behind it. So for example, for the third term, it added 1 and 1. For the fourth term, it added 1 and 2. For the fifth term, it added 2 and 3. For the sixth term, it added 5 and 3. You see that? Everybody see the pattern here? Give me a thumbs up if you're seeing that pattern. Are you seeing that pattern? Who's seeing that little pattern there? So to get the next number, all you have to do is to add the 2 numbers that were before it. Is it? Oh, let me get that. Are we not so sure? We're not seeing it. Talk to me. Are we seeing it or we're not seeing it so clear? Right, well, so, yeah, we kind of think we see it, but we don't really see it. So to get okay, great. All right, seeing that in the chat. So yeah, to get the term, we just add the 2 that were before it, right? So now, if you look at the question here, it says write down the next 2 terms in the sequence. That is U9, the 9th term, and the 10th term. So what would the 9th term be? Remember, to get the term, we add the 2 that were before it. So the 9th term would be what? Which one? Which terms would we add to get the 9th term? Which term would we add to get the 9th term? What are you guys thinking? Right. Yes, the terms that were before, the 13 and the 21, the 7th term and the 8th term. So the 9th term, let me make it a little smaller. 9th term would be 13 plus 21. That is 34. And what would the 10th term be? What would the 10th term be? I think I should leave that there. So, let me write it. So the 9th term is 34. What would the 10th term be? Write the answer in the chat for me. What would the 10th term be? $55, right? So it would be 34 plus the 21, which is 55, right? So just be careful of that. It can look differently, and that's okay if it looks different because it's saying the same thing. So I'm going to let you guys finish up for the second and the third one. I want you to finish up on your own. But just remember, sometimes a sequence, even if it looks differently, then it's still kind of saying the same thing. So we're going to stop here for today. I hope that today's session helped. Does anybody feel like they know a little bit more about sequences? Did it help? The main thing that I want you guys to do is to get some practice. So see if you can get a screenshot of what we have here to finish it. Remember, practice every day. As I said, exam is around the corner. At least 30 minutes, 20 to 30 minutes. Or 30 minutes to an hour, depending on how confident you feel. So make sure that you get some good practice so that you'll be ready for the exam. All right? So remember, if you want some more practice, you can sign up on mymathcamp.com. And if you are not already subscribed, you can subscribe because we want to have these gonna do these workshops every weekend. Went a little bit over time, but it's generally kind of like an hour. We kind of want to spend like an hour, 45 minutes each time, just to make sure that we get a lot of different type of questions. All right. So for tomorrow's session, we're going to look at algebra. So we're going to solve some equations. We're going to look at constructing word problems and stuff like that. So you can kind of keep that in mind. If you want to sign in, same time, and we'll see where we go from there. So yeah, I'll see you guys. I hope it helped. If anybody have any questions, you can let me know. You can always message me and stuff. And then, as I said, I'll see you guys next time. All right. Yeah, I see what you're saying. Ninja Starman. Because we run out of time, we would be able to do it still. But don't worry about it. The next time we'll meet it. Probably what I can do is do that as a video. So that you can get a chance to look at it again. All right, everybody. So have a great evening, and if anything, I'll probably see you tomorrow. Take care. Later.